The level of cholesterol in the blood for all men aged 20 to 34 follows a normal distribution with mean 188 milligrams per deciliter and a standard deviation of 41 milligrams per deciliter. For 14-year-old boys, blood cholesterol levels follow a normal distribution with mean of 170 milligrams per deciliter and standard deviation of 30 milligrams per deciliter. A, let M be the cholesterol level of randomly selected 20 to 34-year-old men, and B, equal the cholesterol level of a randomly selected 14-year-old boy. Describe the shape, center, and spread of the distribution of M minus B. All right. So it said that M follows a normal distribution where the mu of M is equal to 188, right? And the standard deviation of M is equal to 41. Okay, and B follows a normal distribution where the mean of B is equal to 170. And the standard deviation of B is equal to 30. All right, and they want us to find describe the shape, center, and spread of M minus B. So find the mean and the standard deviation, right? Okay, so we know the mean of M minus B is equal to the expected value of M minus B, which, of course, we know this is equal to the expected value of M minus the expected value of B, which is equal to, so the expected value of M is the 188 minus the expected value of B is 170, which gives us that 18. So the mean of M minus B is 18. Now let's find that standard deviation. Well, the variance of M minus B, this is of course equal to the variance of M minus B. Well, the thing is, we know that these two random variables are independent of each other because one doesn't depend on the other, right? M is the cholesterol level of 20 to 34-year-olds, whereas B is the cholesterol level of randomly selected 14-year-old boys. So they don't depend on each other, so they are independent. So because they are independent, we know that this is the same thing as the variance of M plus the variance of B, right? And the variance of M is just the standard deviation of M squared. So this is the standard deviation of M squared plus, and the variance of B is the standard deviation of B squared, which is 41 squared plus 30 squared, which, if you do that calculation, that'll be 2581. Now, we want the standard deviation, so the standard deviation of M minus B is equal to the square root of the variance of M minus B, right? And we found that to be 2581, and then that goes to 50.8. So, we know M minus B follows a normal distribution where the mean was at 18, right? And the standard deviation was 50.8. All right, so now part B, they wanted us to find the probability that a randomly selected 14-year-old boy has higher cholesterol than a randomly selected man aged 20 to 34. Okay, so they want us to find the probability that M minus B is less than 0. Because if the B has a higher cholesterol than M, that means M minus B would be less than 0, right? So this is equal to, so we know M minus B follows a normal distribution, so we can standardize this, Z less than 0 minus 18 over 50.8. And if we do this calculation, that'll be the probability that Z is less than negative 0.35. And let's go ahead and go into our table. So here's our table. We have negative 0.35, which gives us that 0.3632. So the probability that the probability that the cholesterol level of men is going to be less than the cholesterol level of boys is about 36%, right? 0.3632. So, which is the same thing as 36.32%.